Hello students, a warm welcome to all of you in Excellence classes. My name is Aditya Nandwani and here I am going to teach you quadratic equations. Trust me, just give me a little bit of time of yours and I'm going to make sure that you all will be a pro in quadratic equations till the end of this video. But before that, just don't forget to subscribe the channel and press the bell icon for the latest updates of such videos. So students, without wasting much of your time, let me explain you quadratic equations here. So to understand quadratic equations, you have to actually understand quadratic polynomials here. So let me first explain you the quadratic polynomial. So a quadratic polynomial is a polynomial of degree 2. Now let me explain you with a standard equation here. So I have written here a standard equation. Let me write here, that is ax square plus bx plus c. Now in this, as you can see, this x is a variable. So let me write it here, x is a variable here, and this a, b and c are actually the coefficients. So actually a polynomial is a mixture of coefficients and variables. So here you can see there is only one variable, that is x, and the coefficients are in this equations are 3, a, b and c. So I have written down here. So polynomial is a mixture of coefficients and variables. Now the term quadratic comes here. As you can see here, the power of x, actually here the power of x is 2, here the power of x is 1, here the power of x is 0. Now as you can see here, the power is in decreasing format. This is actually the standard format of writing a polynomial. Now the word quadratic means that the highest power of a polynomial is 2. So the word quadratic means that the highest power, or you can say the degree of polynomial is 2. So here the highest power is 2. So this polynomial is a quadratic polynomial here. So as you all now know that the quadratic polynomial is a polynomial whose highest power or degree is 2. Now coming to the topic here, that is quadratic equations. So how will I write quadratic equations? Now there's not much difference between a quadratic polynomial and quadratic equation. They are almost similar, but the difference actually is equal to 0 here. If I place this quadratic polynomial equal to 0, so this will become a quadratic equation. Not much difference here. So this is all the basics. Now coming to this, these a, b and c were coefficients in quadratic polynomial. Here similarly, these are the coefficients of quadratic equation. Now these a, b, c are actually the real numbers here. A, b, c are the real numbers. They belong to a set R. And one more constraint here, that a should not be equal to 0. Let me take this, that if I place 0 here, so what will be the equation? So if I remove this 0, so the equation will be linear equation. When the highest power of any equation is 1, then that equation is called linear equation. Now here we have to deal with quadratic equations, so the highest power should be 2. And for the highest power, there should be a is not equal to 0. That means this a cannot be equal to 0. यहाँ पे ये a जो है 0 नहीं हो सकता, क्योंकि हमारे पास x स्क्वायर के साथ में 0 के अलावा कुछ ना कुछ कोएफिशिएंट होना चाहिए ताकि ये x स्क्वायर वाली पावर एग्जिस्ट करे. This term should exist for a quadratic equation here. So moving forward, let me just explain you the zeros or roots. So what are zeros or roots here? So let me take a standard equation of a polynomial here, that is ax square plus bx plus c. Now let me also take an example of a polynomial for you so you can understand it better. So if I take an example here, that is 4x square minus 3x minus 1. So I've taken an example of a polynomial and denoted it with p bracket x. X, you can see here, is a variable. If I put the value of x1 in this equation, so let me just calculate the value of polynomial. I'm just placing 1 at the place of x. So let me see, just solve it. 1 square 1 into 4 is 4, minus 3 into 1 3, minus 1. So 4 minus 3 will become 1 minus 1. The final value of this polynomial px becomes 0. So I have placed x equal to 1 here in this polynomial, and the value of the polynomial becomes 0. So that value which makes the value of the polynomial 0 is called the 0 of the polynomial. Now similar, this value for the equation is called the root. So if I say this px equal to 0 is the equation, or you can say ax square plus bx plus c equal to 0 is the equation, quadratic equation. So this value x equal to 1 actually is called the 0 or root of this equation. So they are similar. There's not a single bit of difference in the word 0 or root. They are similarly roots for the equation here. That's all. So students, as I have explained you the roots of a quadratic equation, that what are the roots of a quadratic equation, here I am showing you how you will find the roots of a quadratic equation actually. So the first method here I have explained you is factorization method here. So there are 4 steps out here that you will get the final solution, that means the root of an equation. So the first step is write all the terms on one side by making RHS 0. So the first step is you have to make the RHS is equal to 0 and bring all the right hand side terms on the left hand side. So this was the first step. Now moving to the second step, here you have to resolve in linear factors of type ax plus b, cx plus d. That means you have to split it out, the term on the left hand side, and make it in the form of ax plus b and cx plus d. And in the third step, you have to put one by one the factors equal to 0. And finally, you will get the required solution. So this is how you will obtain the roots of a quadratic equation here. That's all. So students, as I have explained you the factorization method, now here I have taken an example of a quadratic equation and I will solve this quadratic equation by factorization method. But first of all, if I see the structure here, I have to convert the structure into ax square plus bx plus c equal to 0. After then I will find out the roots of the equation. So first of all, before applying all steps of the quadratic equation solution by factorization method, I will convert this term by simplifying into this form. So for that, just observe it carefully. What I have to do is, the first step of the factorization method was, I have to simply bring this right hand side term on the left hand side. So see here, x minus 3 2x plus 1 minus this whole term will come in a bracket and the sign will be of negative, as on this side this whole bracket is of a positive sign. So if it comes on the left hand side, the sign will be of negative. So I've brought the whole bracket on the left hand side and make the right hand side equal to 0. So first step was accomplished in the factorization method. First step was you have to make the right hand side equal to 0, and that I have done. Now what I have to do is simplify this. So for simplifying, I can see these 2 brackets here are in the multiplication. So how do we multiply 2 brackets here? I have to multiply the first term of the first bracket with the whole second bracket. So that will be x into this whole bracket 2x plus 1. Simply again the minus 3 will be multiplied by the second bracket, that is 2x plus 1. And now I will first solve this bracket, and that will be, if I say I have to multiply this x with both the terms here. So x into x will be x square and x into 5 will be 5x. And now this minus 12 will be as it is. Now what I have to do is simply multiply this x with both the terms here. So what I will get is x into 2x will be 2x square. And simply x into 1 will be x. Now I have to multiply minus 3 with 2x. What I will get is minus 6x. And again minus 3 into plus 1 will be minus plus minus minus 3. Now when I will open this bracket here, all the signs of the terms will change. So what will happen is this plus x square will become minus x square, this plus 5x will become minus 5x, and this minus 12 will become plus 12 equal to 0. Now I have to find the like terms here. So I can see here this 2x square and x square are the like terms. Now I have to subtract this x square from 2x square. What will the resultant will be x square. Now I have to find the x terms here. You can see here there are 3 terms. So if I solve this, now x minus 6x will become minus 5x, and let me write down the other terms as it is. Minus 5x here, and if you solve this constant terms here, you can see that the minus 3 plus 12 will become plus 9, because minus plus is minus and 12 minus 3 is 9, and the largest term is 12, so the sign will be positive, is equal to 0. Now if you can see here that those two middle terms are in the like terms here. So if I just simply see here that minus minus is plus, so 5x and 5x will be 10x, but the sign will be of negative as both the terms are negative. Now let me write down the other terms as it is. So finally I have obtained this structure. Let me write x here. So this structure is a polynomial if you compare it with this. So now you can see here that I've converted this whole thing into a standard format of a polynomial. So the next step is that you have to make the second step here of the factorization method, and that was you have to simply split this term and obtain the factors that will be of the format ax plus b and cx plus d. Now simply you have to split this term and make factors here. So this was the second step here. So let me just make some space here and show you how you will factors here. So as you have obtained this term here, this polynomial here, now you have to move to the second step of the factorization method. That is that you have to split this term, split this middle term here. So how you will do splitting? So this is our now main motto here. You have to split this term. So for splitting, as you all know, you can see here that this coefficient of x square, that is 1, and the constant term here, that is 9. Now you can see here that this is the constant term. What you have to do is simply multiply these two numbers. So what you will get is 1 into 9, that is 9. Now you have to break this number 9 in two numbers. You have to simply break this number 9 in two numbers so that the product of this is 9. But the addition or subtraction should have to be the middle term here, that is minus 10 here. Now how you will do is, you can see here 9 into 1 is 9, but if I simply add these 9 and 1, what you will bring is 10 here. But you can see the minus sign here. So how you will make this minus here? If I take the larger number as minus and also this 1 as minus here, so minus minus is plus, the 9 plus 1 will take you to 10, and the larger number is 9, so the sign will be of negative here. So these are the two numbers that this 9 should be broken into to obtain the middle term here. So I will simply break this minus 10x into minus 9x minus 1x, as you can see here. Now if I just simply put the side by terms as it is, so it will bring you minus x square and plus 9. So this is finally the splitting of the middle term here. As you can see, this is the rule by which you split the middle term here. So let me just rub it and make some space here. Now let me just observe this first two terms here. So what is common in these two terms? The power of x is simply 1 here, and here the power of x is 2. So there x is common here. Now you can take this x common out here. What will be the remaining in these two terms? You have took 1x out here, so the remaining is 1x. Now minus, you have taken x out here, so what is the remaining? This 9. Now as you have obtained this bracket here, simply what you have to do is take common in the next two terms so that this bracket will remain as it is. So what is common in the next two terms here? You can see here, if I take this minus 1 out here, so what is remaining is this plus 6 and this plus 9 will become of minus 9, as I have taken minus sign outside common here. So this is all. You have to simply make this bracket common here. Now these two terms, if you see here, that x minus 9 is common in both the terms here. So if I take x minus 9 common here, what will be the remaining? This x and this minus 1. So this is how that you split the middle term here and bring out the two factors here. Now just recall the second step of the factorization method. Now, the second step was that you have to break the middle term and make ax plus b and cx plus d factors. If I see this, these are the two factors here. If I compare these two with this, so let me write it down here. That is x minus 9 and x minus 1. So actually these are the two factors here. You can see the power of x is 1 here. So similar, the power of x is 1 down here. So these two are the linear factors here that you have to make through this term here by splitting. Now just come to the third step down. That the third step was simply put these two factors equal to 9, 0. So if I put this x minus 9 equal to 0 as well as this x minus 1 equal to 0, that will bring me the two roots here. So how it is, just simply transfer this minus 9 on the right hand side, that will bring me plus 9. And if I just transfer this minus 1 down to the right hand side, that will bring me plus 1. So these are actually the two roots. This is the required solution of the quadratic equation. So now students, as I've explained you the factorization method, now let me just tell you another method to find out the solutions where you can see the roots of the equation. So here, first of all, I've explained you one method, that was factorization method. And in factorization method there were 4 steps, as you all know, and in second step what you apply on LHS side was splitting. Now, as you know, I'm going to tell you another method to find out the solutions that is pretty much easier than this factorization method. Now, as you can see that in factorization method there were 4 steps, so it is quite a lengthy process to find out the solution. But now I'm going to tell you an easy process, and that method to find out the roots of the equation is quadratic formula. Now, and this actually, let me just tell you briefly that let me just first write the equation here, that is ax squared plus bx plus c equal to 0. This is the standard equation. Now in quadratic formula, the actual formula is, that is x is equal to minus b plus minus under root b square minus 4ac over 2a. Now what are these ABC? These are actually these coefficients here. First you have to find out the values of a, b and c here, and just simply substitute in this formula. That easy. Now first thing you have to know is that this b square minus 4ac value, what is this actually? This is actually a discriminant. This is represented by d, capital D, and its value is b square minus 4ac. This is the discriminant b square minus 4ac here. So you can also write this formula as like minus b plus minus under root d over 2a. So this is how you will find out the roots of the equation. Now as you all know, the highest power is 2, so there will be the 2 roots here. That's why this plus minus sign exists. One value will be of positive, another will be of negative. So this is how you will apply the quadratic formula, as easy to find out the roots of the equation. Now just let me tell you with an example here, but before that let me tell you this, what does this discriminant mean? Actually this just tell you the roots nature. This is another topic which I will deal later. What is the nature of roots? So let me just briefly tell you that this discriminant will tell you the nature of roots. Without actually solving and finding the roots with factorization, you have to simply, if you have given an equation here and you have to tell the nature of the roots, then you will have to find the discriminant by b square minus 4ac. So this will come into play when I will tell you the later questions. But right now you have to just concentrate on the formula here, that is x equal to minus b plus minus under root b square minus 4ac over 2a. And these ABC values can be driven from the equation here. This is a, this is b, and this is c. That's all. So now let me just explain you the word discriminant here. I will take an example here to find out the nature of the roots by the discriminant. But before that, let me tell you what the nature of roots are actually. So before taking an example, here I'm going to tell you the nature of roots. So the nature of roots are of three types here. Let me just tell you the first nature. Before that, let me just write the standard equation of a quadratic. Here is the standard quadratic equation here. So you can easily just know that the highest power is 2 here, so there will be 2 roots. So these 2 roots will be real and distinct. So they can be real and distinct. Both the roots can be real. By real I mean to say these are positive, and distinct means both the roots are different, you can say. So distinct means different. So both the roots are positive as well as different. And in second case, these can be real and equal. So in this case, as you all know, the real means positive, but equal means that both the roots are equal. So you can say you got 2 roots that are 2, 2. So both the roots are equal as well as real. Now, in third cases, that the roots are not real. So not real, or you can say imaginary. So these are the types or the nature of roots. So there are 3 kind of a nature here present in the form of roots. So as I've explained you here, I just simultaneously explain by taking an example and performing it to find out the nature of roots by the discriminant. So now, as I already told you that capital D is the representation of the discriminant. So what was the formula is b square minus 4ac. Let me just write out the standard equation, ax square plus bx plus c again. Now you can extract the values of a, b, c from this formula and just simply put it in here. So now, by discriminant method, how will you explain that whether the roots are real or distinct, or they're real and equal, or you can say they are imaginary? So let me just tell you briefly that there are also 3 cases with correspondence to that. So let me write here the 3 rules here. The first rule for this discriminant method was if your d, that is b square minus 4ac, is greater than 0. That means that your roots are real and distinct. Got it? Now, the second case is that if your d, that is b square minus 4ac, is equal to 0, then your roots are going to be real and equal. The last and the final case is if your d, that is b square minus 4ac, is less than 0, that means your roots are going to be negative. Then the third case exists. That means that the roots are not real, or you can say imaginary. So this is how in sync you will find this. So let me just take an example here so that you can easily correspond this. That's all. So now I have taken an example here so that you can just simply catch out that whether the roots are going to be real and distinct, real and equal, or you can say imaginary by the help of discriminant here. So first of all, look at this example here. So if I just simply write the equation, standard equation over here, so you can easily extract the values of a, b and c. So what are these? A is equal to 2 here, so b is minus 3, c is going to be 5 here. So as I've extracted the values, let me just simply apply the formula here. So that is d is equal to b square minus 4ac. So just I'm going to simply substitute these values over here. So what I will get is just simply at the place of b I will substitute minus 3 here, and the 4 into a, that is 2 here, and c here is 5. So if I just simplify this, so you know that minus 3 square is 9, and this minus square will be positive here. So now if I just simply multiply this, 4 to the 8, 5 to 40 here. So here if I subtract 9 from 40 here, so that will bring me 31, and the sign will be of negative here, as larger digit as of negative. So this is the capital D here. So if I just can see here, that is this discriminant value is actually less than 0. So if I just simply compare it with this here, so I will see that the value of D is actually less than 0. So this means that the roots are going to be imaginary. This is how you're going to get to the nature of roots, by simply getting the value of b. That's all.